So they have given that the first term of the AP is A and the sum of the first P terms is equal to 0. So we know the formula for sum of the first P terms, so it will be P by 2, 2A plus P minus 1 and let the common difference be D. So this thing is equal to 0. Now P is a natural number, so obviously that can't be 0. So this bracket, this whole thing has to be equal to 0. Okay, so the next they have said, show that the sum of the next Q terms is this. So the series will be something like, say it starts from A. So the first P terms and then the next Q terms. Okay, so we know that this whole thing is equal to 0, the sum of this whole thing, and we have to find out the sum of this whole thing. So can we directly just do sum of this whole thing, because the initial part, like the first part, is equal to 0. So the total number of terms that we have will be P plus Q. So now using this, let us write another equation. So that is P plus Q upon 2 into 2A plus P plus Q minus 1D. So this is what we have to find out. Okay. Now looking at this equation, equating it to 0, we can say that now in this equation we don't have D. So our objective is basically to eliminate D from this equation. Now eliminating D using this equation, we can write D is equal to minus 2A upon P minus 1. Okay. Now substitute this D over here and let's check what we have. So we have P plus Q upon 2 into 2A, and then over here we have P minus 1 and we have P minus 1 over here. So let's just write this as minus 2A and we are left with Q. So that will be plus Q into minus 2A upon P minus 1. Okay. Now cancel out 2, 2, 2, 2. This A will cancel out with A. And finally, we are left with P plus Q minus A upon P minus 1, and this is the same as this, hence proved.